death. It remains the ultimate mystery, a question that has haunted humanity since the dawn of consciousness. What happens when we take our final breath? Do we simply cease to exist, or is there something more? In 2016, a team of scientists in Canada stumbled upon a tantalizing clue, a glimpse into the dying brain that offered a potential answer. The case involved an 87-year-old man who was undergoing treatment for epilepsy. During a brain scan, the unexpected happened. The patient suffered a fatal heart attack. This tragic event, however, presented an unprecedented opportunity for researchers. For the first time, they had a recording of the brain's activity in the moments leading up to and following death. The findings were nothing short of remarkable. As the man's heart stopped and blood flow to his brain ceased, there was a surge in electrical activity, particularly in the gamma wave frequency. Gamma waves are the highest frequency brain waves and are associated with heightened states of consciousness, such as memory recall, dreaming, and meditation. The presence of these waves in the dying man's brain led scientists to speculate that the surge in activity could be the neurological basis for the phenomenon of life flashing before our eyes. Could it be that in our final moments, our brains replay key memories and experiences? The idea is not entirely far-fetched. Near-death experiences often involve vivid recollections of past events, and the similarity between these accounts and the observed brain activity is striking. Some people who have experienced near-death experiences describe it as a profound and deeply personal journey, often accompanied by a sense of peace and serenity. If the 2016 study is any indication, these experiences may have a biological basis rooted in the intricate workings of our brains. Despite the intriguing nature of the findings, it is important to note the limitations of the study. The patient in question had epilepsy, a condition that affects brain activity, and was on medication, which could have influenced the results. Additionally, there was no baseline measurement of the patient's brain activity before death, making it difficult to determine whether the observed surge in gamma waves was typical or an anomaly. It is also worth considering that the study involved a single individual. More research is needed to determine whether similar patterns of brain activity occur in other dying individuals. The findings, while thought-provoking, should be interpreted with caution until further evidence is available. The 2016 study, despite its limitations, has sparked a renewed interest in the scientific study of death and dying. It highlights the potential of neuroscience to shed light on one of life's greatest mysteries. The human brain is an incredibly complex organ, and we are only just beginning to understand its inner workings. Projects like the Human Connectome Project, which aims to map the brain's neural connections, are providing valuable insights into how our brains function and how they are affected by disease. As our understanding of the brain grows, we may one day be able to answer the age-old question of what happens when we die with greater certainty. Perhaps more importantly, this knowledge could have profound implications for how we approach end-of-life care, helping to ensure that individuals experience death with dignity and peace. The journey into the mysteries of the brain is ongoing, and the 2016 study serves as a reminder of the vast, uncharted territory that lies ahead. As we continue to explore the inner workings of our minds, we may finally unlock the secrets of life and death.